So a package of mass 4.0 kgs explodes into 3 pieces. One piece with the mass of 1 kg moves with the velocity of 9 meters per second east. Another piece with the mass of 2.0 kgs moves with the velocity of 6 meters per second north. Calculate the velocity of the third piece. So there is this package, right? And then suddenly the package explodes into 3 different pieces. One piece is going north. One piece is going east. And then another piece, like I'm assuming it's probably going to go in this direction. The mass we're going to call M1. We know it's 1.0 kgs. And it's moving at a velocity of 9 meters per second east. Of 9.0 meters per second east. We know that the mass of this one, M2, is 2.0 kgs. And it's moving at a velocity of 6.0 meters per second north. The total package is 4 kgs, so 3 kgs make up these two masses, so the mass of this one has to be 1 kg. And we need to find the velocity of this. So for solving questions like these, we need to remember that the total momentum before is equal to the total momentum after. And since this is a 2D question, we need to split it into 2 components, the x component and the y component. So the total momentum before in the x component is equal to the total momentum after in the x component, and same with the y. So with that in mind, let's find the total momentum before. Since this package is originally at rest, right? It does not explode yet, so it has a momentum of 0 at the start, and then it explodes into 3 different directions. So M1 V1 plus M2 V2 plus M3 V3. So we know for sure that M2 V2 only goes, well, this mass is called M2, but it only goes one direction, and that's north. It has zero velocity in the x direction. So we're going to cancel that out. So what we are left with is M1 V1 plus M3 V3. Isolating for V3 gives us M1 V1 over negative M3. We can plug in what we know. So this gives us negative 9.0 meters per second east, or 9.0 meters per second west. Okay, we'll do the same thing for y. So before, the momentum in the y is also 0, and then we have afterwards package exploding into 3 different directions. So M1 V1 plus M2 V2 plus M3 V3. Now, looking at M1, we know that it's 9 meters per second east. It has no velocity in the y direction, right? So we will cancel that out. So we're left with M2 V2 plus M3 V3. Isolating for V3, we get M2 V2 over negative M3. So we get negative 12 meters per second north, or 12 meters per second south. So we have the component in the x direction and the component in the y direction. And with that, we can find the resultant velocity. So in the x direction, it goes 9.0 meters per second west. And in the south direction, well, in the y direction, it goes 12 meters per second south. So we can find this resultant velocity that I'm going to call v. Okay. So there's an angle created here, and to find that angle we can use trigonometry. So tan inverse of 12 over 9. This gives us 53.13 degrees. And V can be found using the Pythagorean theorem. So 12 squared plus 9 squared. So V is equal to 15. And west, 53.13 degrees south. So this is our velocity of this third piece of the package.